Hi everybody! We are finally going to move away from chapter 5 and today we are starting chapter 8. I know we're jumping from 5 to 8. Chapter 8 makes the most sense to kind of jump to next because we're still doing a lot of factoring. If we just went in order, chapter 6 jumps to fractions for exponents and things like that. So we're going to jump to 8 while factoring is still very fresh in your mind. And this is where we are going to have fractions or rational expressions, and we are going to have to factor within them in order to simplify, to multiply, divide, and all of that. Okay, so this week we're going to focus on section 8.4. We only actually do a couple sections from this chapter. We're only going to look at 8.4, 8.5, and 8.6. This entire week, we are just doing 8.4. We're going to take it nice and slow since I don't actually get to see you in person to teach this to you. Okay, so jumping right in, simplifying is for today. Tomorrow, or the next video, would be multiplying, and the video after that will be dividing. But if you understand simplifying, then multiplying and dividing should be pretty easy as well. All right, so today for simplifying, let's get started, shall we? All right, so the first part, just recognizing what a rational expression is. It is the quotient of two polynomials. Quotient just means divide, and fraction bars we know mean divide. So really a rational expression is just when you're dividing two things. So notice in the first example there, this one is just going to show us you have a monomial divided by a binomial, one term, and this is two terms. On this one, you have two terms, a binomial divided by three terms, a trinomial. And this one has a trinomial on top and just a single term on the bottom. So it doesn't really matter. That's just, different ways that we can kind of look at these. So in a simplified rational expression, the numerator and denominator have no common factors other than plus or minus 1. So in other words, looking down here at an example, we have AC over BC. And this is the point where I would ask you guys, for this one, what do we want to, or what could we cancel? So looking here, we can cancel, we have a C on top and a C on the bottom. So then we could simplify this to just A over B. There we go, my pen stopped working there for a minute. A over B. Now the big thing where students have trouble is looking at, this is A times C and B times C. Multiplied like that, we can kind of cancel things out as we please. Now, had that been A plus C over BC, where the A and C are being added, we would not be able to cancel those C's out. Okay, if things are held with a plus sign or a minus sign, so same thing, A minus C over BC, we cannot cancel out. If it's held with a plus or a minus, you either cancel out the entire piece or you don't cancel it at all, okay? So it has to have a no plus, no minus. If it's just pieces being multiplied, you can cancel things out like crazy. But here, you cannot cancel those C's because they are held with either a plus sign or a minus sign. So some examples for you of not simplified versus simplified. We would look at, we have the first one, you have an x minus 2 on the top and an x minus 2 on the bottom. We can cancel those out, right? As long as you cancel the entire piece that's being added and subtracted together, you can cancel those. So then you'd be left with just x plus 3 and x minus 3 on the bottom. Notice we did not cancel the x's and the 3's. Canceling those does not make sense. That would be like me asking you, let's see, 2 plus 3 over 2 minus 3. Well, I can't cancel the 2's and say that that's 3 over negative 3. That doesn't make any sense. Or let's cancel the 3's and then I have just plus over a minus, right? That makes no sense. So what we need to do with this, since one's held with a plus, one's held with a minus, they are not the same terms. So that is as far as we can go. Okay, the only time you cancel is if it is being multiplied. Those are being added and subtracted, therefore they are one common piece. That plus and minus, they glue them together. We cannot touch those. All right, on the next one though, we have an entire x squared plus 4x plus 3 on top x squared plus 4x plus 3 on the bottom, I can actually cancel the entire piece because they are exactly the same. Now, a lot of times people want to cancel these and they're like, oh, so my answer's nothing, it's gone. Well, technically it's not gone, it's 1. It'd be like if I had given you like 5 over 5, you wouldn't cancel that out and tell me nothing. If I have 5 cookies and I give them to 5 people, each of you would get 1 cookie, right? 5 divided by 5 is 1. So they are canceling kind of, but when you cancel things out, technically there's still a 1 there. Now, if we look at the last example, these are not held with a plus or minus. So you can go ahead and kind of just cancel what you want. So I have 1x on the bottom that's going to cancel out, and it would take one of these x's away. So instead of there being x squared, or 2 of them, right, because x squared means x times x, means you have 2. So technically I was canceling one of those x's out and leaving just one of them left over. And then 4 and 8, just how you think about simplifying fractions. I can divide them both by 4, right? So 4 divided by 4 is going to change that into a 1, and 8 divided by 4 is 2. So that's why we have 1x over 2, or in other words, just x over 2 left over. All right, the next thing I want to talk about, and then we'll get some practice of all of this together, is restrictions. Restrictions, I teach it now because I know in section 8.6 we are going to be talking about solving, where you're going to actually solve these for x, and you have to recognize that sometimes when you solve things, you get answers that show up that aren't real. Right? They can't actually be an answer. Which we kind of know those then as extraneous solutions, extra answers that show up that actually don't work. So this is very similar to that. But I figure if I teach it now, then when we get to solving, instead of you learning all of it at once, then it makes more sense to you, and we can kind of just fall quickly in line. It's worked out great in years past. I'm sure it'll be fine here. In other words, restrictions, to make this simple for you guys, if you look here, the domain, or the x values, include all real numbers except for numbers that make the denominator equal 0. Right? Remember, if you guys think back in class, I played the Cookie Monster thing when I asked Siri about Cookie Monster. And it talked about 0 divided by 0 and how Cookie Monster's sad and has no friends. But back to that, you can't divide by 0. Right? If I did 3 divided by 0, you can't, right? That's undefined. Type it in your calculator. It gives you an error message. You cannot divide by 0. Now, 0 divided by anything else, well, that's just 0, so that's fine. But 0 cannot be in the denominator. So, numbers that make the denominator equal 0 can be referred to as restrictions. They are things that x is not allowed to equal. So if we look here at the first example, on the bottom, you have an x minus 3 and an x minus 2. Well, x minus 3 cannot equal 0 because then you would have a 0 times something, which is 0, which is not good. You can't have 0 in the bottom. This only applies to the denominator, right, or the bottom of a fraction. You cannot let that equal 0. So x minus 3 cannot equal 0. If we solve, that means x cannot be 3. And then x minus 2 cannot equal 0, right? That's also in the denominator, which means x cannot equal 2. So if I ask you what are your restrictions, well, x cannot be 3 and x cannot be 2. Now again, kind of thinking ahead into section 8.6, where what does all this mean? That means if you knew what your restrictions were ahead of time, then when you get into solving and you're like, yeah, x equals 4 and 3, and you'd be like, well, no, I have x cannot be 3, that would be an extraneous answer. So learning this now helps when we get to solving to make that a lot easier. All right, on the next problem, 8x is on the denominator. Well, whatever your denominator is, 8x cannot equal 0. So solving this one, we would know then that x cannot equal 0. So in order to find your restrictions, which I will ask you to do on every problem, you just take whatever is in your denominator, set it equal to 0, or in other words, set it not equal to 0, solve that, and then you'll see what x is not allowed to equal. All right. At this point, this is in your notes, you're going to want to highlight, circle, star. Every time I'm going to break these down for you in steps, trying to help you guys out step by step what to do. In years past, a lot of times students would raise their hand, I'd go over and they'd be like, I have a question, and like, I don't understand what I'm doing. So I would always ask them, well, what set of steps are you on? Because you're going to have one fraction, you're going to have adding, subtracting, multiplying, dividing, you're going to have all those. And they could always tell me which one they should be on. And then I would literally stand there and read the steps for them. I wouldn't do anything other than to read, all right, step 1 says to factor. They would factor. And then I'm like, I don't know what to do next. I'm okay. I'm like, well, step 2 says restrictions. And they would do that. And then like, now what do I do? I'm like, well, step 3 says to cancel. So literally I wouldn't actually teach them when they had questions. I would read them their steps. I'm pretty sure all of you are capable of reading. Okay, so when you are stuck, that's what I want you to do. You need to go back, find your steps, and figure out which column you're on, which part of your steps. And I will post for you also the like a flow chart, step-by-step guide. I'll post that separately so you have it all in one spot for you. But figure out where you belong and then just read your steps. If you need to, pretend it's me reading them to you, if that helps, okay? But read your steps. It's going to tell you what to do. All right, so here we go. So number 1, step 1 says to factor. Now, if nothing has a plus or a minus sign in it, then we can't factor. All right, think back to your factoring flow chart. You have things with 2 terms, 3 terms, and 4 terms. That's how we factor things. If I look here at numbers 1 and 2, actually, these are all just one term, right? 15x squared, that's one term. 20x to the 5th, that's one term. I can't factor something with one term. If I look at number 2, 24x cubed y squared, it's a really long term, but it's just one term, right? There's not a plus or a minus separating it into different things. Whereas if I look at number 3 has x squared plus 2x minus 8. Well, that's 3 terms, right? They're separated by plus and minus signs. All right, so back to number 1. Step 1 factor, I can't, right? It's only one term. Step 2 says restrictions. So I'm just going to use oh, that was terrible. My board is acting very strange today. Sorry. All right. So I'm just going to use an R for restrictions because I'm too lazy to write out the full word restrictions. Whatever your denominator is, so 20x to the 5th cannot equal 0. Denominator not equal to 0, and then you solve. So if I divide by 20, and again, I'm going to go step by step, but some of you probably can already see what it's going to be. X to the 5th cannot be 0. How do you undo an x to the 5th? Well, technically it's the 5th root. And hopefully you don't need a calculator to realize the 5th root of 0 is 0. X cannot be 0. Now technically, if you think back to our last chapter, you'd be like, well, shouldn't it be 0, 0, 0, 0, 0 because of x to the 5th? Yes, sure. But you're just telling me what x cannot be. If you want to tell me x cannot be 0 5 times, that's fine. You can do that. But it's kind of an overkill. X cannot be 0. So that's my restriction. And then step 3 says to simplify. Now that's a very vague term, but simplifying is just kind of looking at step 3 was cancel. Canceling just anything on top and anything on bottom. So I see I have an x squared and an x to the 5th. So I can cancel 2 x's from the top, which would leave this one then with an x to the 3rd. And then I have 15 and 20. I can divide those both by 5. So 15 divided by 5 is 3. And 20 divided by 5 is 4. And then just looking what I have left, I have a 3 on the top, and I have a 4x to the 3rd on the bottom. And I'm done. That is simplified. All right, number 2. Number 2, first thing we need to look at, step 1 says to factor, and we talked previously already. On the top and the bottom, they're each just one term, so I can't actually factor them. So I need to look at my restrictions. So that's where you would set your denominator not equal to 0, because that's what it's not allowed to be. And notice again, this is just like -6 being multiplied by x squared, being multiplying by y. So in other words, what can you not multiply by? What are you not allowed to multiply? Because it would give you a 0. So in this case, x and y, neither one is allowed to equal 0. Because again, I could just divide by -6, which is still a 0. You take the square root or take the cubed root, and you still just get 0. So x and y cannot be 0. Those are my restrictions. And then moving back up to the top here. So then I need to, step 3 says cancel. So it's all fair game since it's not held together with plus and minus signs. So I can cancel 2 of the y's with this down here, so there'd be just the 1 y left. I can cancel 2 x's from the bottom, would leave just the 1 up top. And 24 divided by -6, or I can divide them both by -6. 24 divided by -6 is -4. -6 divided by -6 is just 1. So I have -4x on top, and I have 1y, or just y, left on the bottom. And we're done. All right, number 3. Step 1 says to factor. This one I can actually factor. So the top I can factor. All right, last one is negative, so I know my signs are plus and minus. Options for A is x and x. Options for C is 1 and 8 or 2 and 4. It's going to be a +4 and a -2. On the bottom, we can factor that one. The last one is positive, which means they're going to be both minus. I have x and x. I have 1 and 6 or 2 and 3. Now, here's where people make, excuse me, sorry about that. This is what I refer to as the dreaded, the dreaded 6-5 combo. Reason being is I have that 6 on the end. 1 and 6 can make a 5. 2 and 3 can make a 5. So you need to be very careful about your signs. That's why I always fill my signs in first. So if I did, knowing they're both minus, -1 and -6 make -7. -2 and -3 make -5. So it has to be the 2 and the 3. All right, that is factored. Step 2 says restrictions, so let's not forget those. So restrictions, that is where I would set each part on the denominator, only the denominator, not equal to 0. And then I would solve. So x cannot equal 2, and x cannot equal 3. All right, those are restrictions. Again, when I get to section 8.6 and solving, that's going to help me out tremendously. All right, and then it says cancel. So any top with any bottom. So again, I see I have an x minus 2 on top and bottom. I can cancel those. So I am left with an x plus 4 on the top and an x minus 3 on the bottom. And every year, somebody's like, oh, I can cancel the x's. No, you can't. You cannot cancel those x's. Right? If something is held with a plus sign or a minus sign, you cannot break those apart. That is like super glue, right? Those do not break apart. You either cancel the entire set, like we did the x minus 2's, or you just have to leave them be. You can't cancel just part of them. All right, let's try just a few more and we'll call it good for the day, okay? So back to our steps where you always want to look. Step 1 says to factor. All right, so first thing on number 4, I want to factor the top. That's going to factor to an x plus 4 and an x plus 1. The bottom factoring, that is my favorite. That is a difference of squares. So I know it's x plus 4, x minus 4. Now be careful, don't jump the gun because your next step is restrictions. All right, don't cancel yet. You have to do restrictions before you cancel. So looking at restrictions, that is your denominator. So x plus 4 cannot equal 0. X minus 4 cannot equal 0. So then I know x cannot be negative 4, and x cannot be a positive 4. So those are my restrictions. All right, and then step 3 says to cancel. So looking, I can cancel. I have an x plus 4 and an x plus 4. So all I have left is x plus 1 over x minus 4. Can I cancel those x's? No, don't cancel those x's. I can't cancel them, right? If they're held with plus and minus, it's like super glue. So don't touch those. All right, number 5. Hopefully you recognize something on number 5 right away. The numerator, the top, it's not in standard form. So that should be negative 4x plus 12. We always want to make sure we start out in standard form. Otherwise, we have a lot of issues moving forward. All right, so the first thing we want to do after we rewrite it, step 1 says to factor. The top, I can factor out a negative 4, left with x minus 3. More students than ever, you're going to mess up on these because you're going to forget to look for the GCF. Okay, make sure you're looking for that. On the bottom is my favorite, x plus 3, x minus 3. It's a difference of squares. So everything's factored. Step 2 says to cancel. I'm sorry, that's step 3. Step 2 says restrictions. So my restrictions, again, the denominators, x plus 3 cannot be 0. X minus 3 cannot be 0. So we solve each of those. So x cannot equal negative 3. And x cannot be a positive 3. So when I get into solving in 8-6, I'm going to be ready to go for that. All right, and then step 3 is cancel. Canceling always seems to be the last thing we do. So if you're canceling and you're not done yet, you know you did something wrong. All right, so step 3, cancel. Let's see, any top, any bottom, I can cancel the x minus 3's. And I'm left with negative 4 over x plus 3. Notice I put parentheses in the bottom there. You can, if you prefer to see that. I know I've had students in the past, anything that had a plus or minus attached to it, like holding it to something, they like to see the parentheses around it. It kind of showed them it was a group. So if that makes you more comfortable, you can do that. If you're cool without it, that's fine as well. Okay, whatever works for you guys. All right, let's take a look at number 6. Last problem for the day, guys. Not sure if you recognized it, but right there, what do you notice about those? Those are like terms. So let's go ahead and rewrite, putting our like terms together there. So I just rewrote my top, that one's fine. On the bottom, that's going to give me 15x squared plus 9x. So just be careful that you're watching for things not being in the right order, right, like on number 5, and that you're watching for like terms. Sometimes those are sitting there. All right, so step 1 is to factor. From the top, I can take out a 3x squared. Then I'd be left with 3x plus 2. On the bottom, I can take out a 3x, and I'm left with 5x plus 3. Restrictions. So setting the bottoms equal to 0, or not equal to 0. So 3x cannot be 0, and 5x plus 3, sorry, my board doesn't like me to write this small, cannot be 0. So we get x cannot be 0 from the first one, and x cannot be negative 3/5 for that second one. All right, and then when I look to cancel as my last step, the 3x plus 2, 5x plus 3, nothing cancels there. But notice in the front here, these are not held with a plus or a minus. Since they're not held with plus or minus, I can kind of piece them out. I can look at them one piece at a time. So 3 divided by 3 is 1, 3 divided by 3 is 1. I have 1x here I can cancel out with one of them up here. So I'm left with 1x, or just x, and then 3x plus 2. And on the bottom, I just have a 1 out in front, and then I have a 5x plus 3. And I'm done. All right, guys, that's it for today on simplifying. If you need extra help, feel free to reach out. Join in one of the video chats we have scheduled for the week. And if you need anything at any point, anytime, please always ask, okay? I'm here to help you guys. All right, so when you're done with this video, go ahead and work on the homework problems, make sure you got it, and then take the quizzes. All right, guys, we will see you later.